Hello my dears. So today we are going to discuss about integrators. Integrator using op-amp. Okay. So this is a basic circuit diagram of integrator using op-amp. So integrator is nothing but the circuit which produces the output voltage, which is nothing but the integral of the input voltage. I already mentioned in the last class that whenever we have to control the gain of an op-amp, any circuitry using op-amp, integrator, differentiator, logarithmic amplifier, summing amplifier, differential amplifier, anything, any circuitry, if you have to control the gain, then definitely there should be a feedback. And open loop gain, op-amp which will not controllable in the gain. I mean the gain cannot be controlled. So if you want to control the gain of an op-amp, definitely we should need some feedback components. Okay, so here this is very simple circuit actually. Integrator is nothing but a very simple circuit which produces the output voltage is an integral form of the input. Let's see how that happen. Okay, let's see how that happen, my dears. So listen. See, there is a current I imagine there is a current I, okay, I which is flowing in the circuit. And see, my dear, due to the virtual short, I already explained in the last class that there will be a virtual short happens. So due to the virtual short, the same voltage will, suppose this is 0 volt here and this will be also 0. That means there will be high impedance path following. There will not be any connection normally, because the impedance of the op-amp is very high. So the same current I will be flowing here also. That is the first assumption. Then I applying KVL here. So at this junction I am going to apply KCL. Okay, in the junction I am going to apply KCL. So what will be? I can say one thing, that the same current will be same. The current through the resistor is same as this one. So that I can like this, let be IC and let be I1. Imagine. Okay, so how can I write like I1 will be equal to what, my dear? IC. Am I right like this now? I1 is equal to what? IC. So I1 is nothing but how can I write I1 here? How can I write I1? See, this I1 is nothing but, my dear, V input, correct now, minus 0 divided by this one. This is nothing but R. Is it clear? And which is equal to 0 minus V output, right? 0 minus V output divided by XC. Okay, or other equation also can be written. V input divided by R is equal to what is the current across the capacitor? IC is nothing but, my dear, C into d by dt of voltage across the capacitor. Am I right? VC. Let VC be the voltage across the capacitor, then C into d by dt VC. Or I can write like C into d by dt of what is VC now? VC is nothing but the voltage here minus voltage there. Difference in voltage is nothing but the voltage across the capacitor. So I can write like C into d by dt of the voltage here is nothing but 0 volt and the voltage outside is nothing but V0. Am I right, my dear? So I can write like minus C into d by dt of V0. Correct? So that I can write like V input divided by R is equal to what? Minus C into d by dt of V0. Or in other words, I can write like V input divided by R into dt is equal to, am I right? dt is equal to minus C into dV0. Or in other words, I can write like V input divided by RC minus V input divided by RC dt is equal to dV0. If you want to find the V0, that is nothing but the output voltage, take integration on both side. So I can get like integral dV0 is equal to minus integral of V input divided by RC dt, or in other words, my dear, V0 is equal to minus 1 by RC integral V input dt. So this is the expression of the output voltage of an integrator. This is the expression of the output voltage of an integrator. Okay. So that's all about. That means both equations are there. V input minus 0. You can use this equation. This equation also useful, but it will give to other form. The output will be same. I mean, finally you will get the same answer, but this will be easier. This equation will be easier. That's why. So that's all. Okay. So this is nothing but the ideal integrator circuit. Now, for practical integrator circuit, my dear, there are some problems. There are some limitations in the ideal integrator circuit. That means one limitation I will tell you now. Suppose the frequency of the input voltage is 0, then what happened? The capacitor will offer like a open circuit condition. Correct now? The capacitor will be an open circuit, because if the frequency 0 means there also exists a 0 frequency wave, which means the capacitor will be Xc is equal to 1 by C omega now. So omega will be 2 pi f. So frequency will be 0 means Xc will be infinity. The capacitor will not exist there. If there is no capacitor, means the integration action will not be there. The integration action will not be there. That means the gain will be a constant. There will not be any integration. So that is one limitation. And another limitation you can say like, see the input impedance now, that is main limitation. So in order to avoid that limitation, there will be in practical integrator circuit. This is nothing but, my dear, ideal integrator circuit. Okay. This is ideal integrator circuit. I will tell you the practical integrator circuit. In practical integrator circuit, the change is nothing but practical integrator circuit. Okay. Practical integrator circuit, there is a small change for overcoming that problem. There will be a resistor. There will be a resistor. That's all. That is already one resistor. There will be RF and there will be CF. There will be R and this will be P input. Only this change will happen. That means in practical integrator circuit there will be one more resistance, because whenever there is what happened when frequency equal to 0, their inductor will, the capacitance will not be there. If there is no capacitance, means there is no feedback. That means we cannot control the gain. That situation will happen. The gain will be constant, we cannot control that. Whenever the change of frequency happen, the gain will not be controllable. For overcoming that, there will be a feedback resistor also we can add in parallel with the capacitor, so that even if the frequency is 0, the capacity is like an open circuit, there still exists a feedback path, so that we can control the gain of the amplifier. So that is why we are using the practical integrator circuit, we are always using a feedback resistor. So this is enough for your sub-engineer level of examination, or up to the A level of examination, it's enough. Okay, there is a frequency response curve, many equations or like many things are there, but for competitive examination point of view, this is more than sufficient. Okay, the circuit diagram is very important, and the equation, that's all very important. Okay, and if possible, small problems also there, you can directly substitute, you will get the answer. Is it clear? You can directly substitute, you will get the answer, my dear. Okay, so that's all. That's all about the integrator. Now let's see what is differentiator. What is a differentiator circuit? What is a differentiator circuit? Differentiator. Only a minute change in the differentiator circuit, my dear. I will draw this. Only a minute change there. Okay. the capacitor will be there and a resistor will be there. That's all. V out, V input, and this is VC and this is V out. That is the only difference. So if you know the integrator, definitely you can easily just what is the correct word? Replace this R with C, that's all. Replace this R with that C, that's all. Okay, interchange R and C, that's all, simple. So let's see what is the relation between V out and V in. Okay, so differentiator is nothing but, in order to find the rate of change of input voltage, we are using the differentiator circuit. Or in other words, whatever the quantity we are giving as the input to the differentiator, the output will be the differentiated one. The output will be nothing but d by dt of the input will be the output. Okay, that we will discuss now. Okay, so let's see again the same concept we are using here. Suppose here it is 0 volt means here also 0 volt due to the virtual short or virtual ground property that I already explained. Let the current here be IC and let the current here be I1. Okay, so due to the virtual ground property, we can say that this IC will be same as I1. IC will be same as I1. Okay, right? So what is this IC, my dear? IC is nothing but, my dear, C into d by dt of VC. Correct now? C into d by dt of VC is nothing but IC. Same equation. And I1 is nothing but, suppose here it is 0 volt. Okay, I1 is nothing but, my dear, 0 minus V out, simply V0 divided by R. So I can write like C into d by dt of, what is VC must nothing but voltage across the capacitor, which is nothing but V input minus 0, which is equal to minus V0 by R. Am I right? Or in other words, my dear, or in other words, C into d by dt of V input is equal to minus V0 by R. Or simply I can write like, my dear, V0 equal to minus RC into d by dt of V input. That is the equation of the differentiator. That is the equation of the differentiator. Is it clear, my dear? That is the equation of the differentiator. So in practical differentiator, there is again some capacitor can be added. Some capacitor can be added in order to stability, in order to get the stability. Okay, so that is not that much important. So this equation is very, very important, my dear. Okay, for a sub-general level examination, for A level exam, this is equation is enough. So V0 is equal to minus RC into d by dt of V input. So whatever may be the input voltage we are giving, we will get the differentiated version of the input voltage. Okay, so that's all about the differentiator. Next one. Log amplifier. Log amplifier. You just need to know the circuit diagram ideas, nothing more, nothing more. Only circuit diagram will be asked. Circuit diagram is very, very important. Okay, circuit diagram will be asked. Simple, a diode. A diode in the feedback path will create, suppose this is R and this is the input voltage. This is the input voltage. And the output will be nothing but, my dear, the output will be nothing but the log of the input voltage. Log Vn will be the output voltage. Okay, there is some more factors are there. A very large derivation is there. After that it only to obtained. But for derivation is not our, means a cup of tea, no? Which is very big derivation. So we don't want that. Simply log amplifier circuit is this much. Another one is anti-log amplifier. What is that? Anti-log amplifier. Okay, see, the circuit diagram is also very similar. If you know the logarithmic amplifier, the circuit diagram of anti-log is very, very easy. This is R and this is D. V input. This is nothing but V output. Simple. Only you have to know the circuit diagram here, nothing more, nothing less. Okay. So that's all about the different circuitry using the logarithmic amplifier. Some more circuits are there that we will take in the next class, like Smith trigger and all, because Smith trigger needs some explanation. That's why. And now we are going to discuss about a very important session which continuously asked in the previous year papers. That is the most important session in the op-amp, but it is very easy. It is nothing but CMRR, common mode rejection ratio. Common mode rejection ratio. Ratio. It is the most important portion in the op-amp circuitry. As far as for electrical students, no. If whenever you just see the latest question paper, electrical inspectorate examination, there was one question regarding the CMRR. So every question paper, if you refer, there will be one question regarding CMRR. So this is that much important, my dear, that much important. No one will ask you the concept, only problem you have to focus. Examination point of view only we have to study, my dear. We don't want to mug up everything, we won't want to load everything on our head, no. For examination point of view, what they ask, simply study that only, okay. So what is mean by the CMRR, my dear? CMRR. Normally in op-amp there will be two input, my dear. One is in non-inverting terminal and other one is the inverting terminal. Okay. So ideally, see, whenever this V1 and V2, so what is the equation for V0? V0 is nothing but A into V1 minus V2. Okay. So ideally, if V1 equal to V2, that means I am applying same voltage here. What will be the output voltage? V0 will be equal to what, my dear? 0 volt. Am I right? Am I right? But practically, even if V1 equal to V2, there exists a small voltage due to input offset voltage. Okay, makes small output voltage, you can let output voltage, small output voltage due to input offset voltage, okay, that's all. So CMRR is nothing but, my dear, CMRR is nothing but differential mode gain divided by common mode gain. Differential mode gain divided by common mode. That means what will be the gain of an op-amp whenever it is in differential mode voltage? Differential mode voltage is nothing but V1 and V2 are different. Then what will be the V0? Simply A into V1 minus V2. Simply A into V1 minus V2. And what will be the gain of the op-amp when it is common mode voltage? Common voltage is nothing but just V1 and V2 same. At that time there will be some voltage, because I already told you that these are man-made elements, that op-amps, and inside the op-amp there are so many transistors, and definitely I can tell you each transistor will vary in minute what? Factors. Each transistor will vary in minute factor. That minute factor makes not the non-equality between the two transistors. That will make, even if you apply the input side superb equal, the output will not be equal. I mean the output will not be 0. Normally the output will be 0, A into V1 minus V2. By equation the output should be 0. But even if you make the input was to be superb equal, due to the dissimilarity, small dissimilarity between, or small manufacturing difference between the two transistors inside the op-amp, what happen? There will be always some output voltage across the differential output. That means across the op-amp, because of the imperfection in manufacturing of two transistors inside. Okay, and even if you are, and the transistors is also connected by some resistors. We can't make, suppose 10 kilo ohm resistor is in your hand. You can't exactly create another 10 kilo ohm resistor. There will be small variation there will be in the range of milli ohm. There will be some variation. So these resistors are connected inside the transistors, inside the op-amp, because the transistor differential amplifier is nothing but different two transistors connected in different manner by some resistors. So that resistor also we can't make that equal. So what happened? There will be some input offset voltage. Is it clear? Due to that, there will be an output voltage. Okay. So what is meant by CMRR is nothing, differential gain by common mode gain. So this is the theory of that CMRR, but no one will ask you the theory. The problem will be asked. Let's discuss a problem. Let us discuss that problem. We will take the same problem in the electrical inspectorate exam. Okay. Let's find the option will be there or not. Okay. Let's find my dear. Okay. And see, my dears, in the question it's given that CMRR is equal to 100 dB. CMRR equal to 100 dB, and they are given the differential mode gain as 10,000, I think, and we have to find the common good. That's all. That is the question. I'm going to solve it now in one step. Okay, you will wonder. So CMRR is 100 dB. So there is an equation. Normal CMRR is nothing but, my dear, differential mode gain by common mode gain. We all know this. And CMRR in dB is nothing but, my dear, 20 log AD by AC. Just to take 20 log, that's all. 20 log, that's all. You will get the dB. So dB answer is given right now. So 100 dB is given. It is nothing but 20 log of AD. AD is what? 10,000 divided by AC. You have to find. Take a 10. If you want to remove the log, you have to take e raised in both sides or 10 raised to on both sides. So this is nothing but 5. So 5 is equal to log of 10,000 divided by AC. So take 10 raised to 10 power in both sides equal to e raised to, both the same. So 10 raised to 5 is equal to simply 10,000 divided by AC. That's all. Or simply AC is equal to 10,000 divided by 10 raised to 5 means this much, na? Correct, right? 10 raised to 5. 1, 2, or 5. 5 zeros, correct? And this is 10 raised to 4. So it will be 0.1. Correct? 1 by 10 will be 0.1. So 0.1 is the answer. That is already in the option. That's already in the option. Correct? 10 cubic 1000, no? It is 10 raised to 4 divided by 10 raised to 5. Correct, my dears? Correct? 10 raised to 4 by 10 raised to 5, 0.1. This is the answer. So common mode gain, na? Common mode gain. So this is the gain is what? A unitless quantity, right? Is it clear? Is it clear? So that's all about the question, my dear. That's all about the question. Okay. So that's all for today. We'll meet again tomorrow with a new session. Until then, bye. Take care.